Hello everyone, welcome to Learn Overflow. In this video, we'll discuss about today's LeetCode problem, that is the poor pigs. This is a heart level problem and we'll understand how easily we can do this question. I will explain you step by step and you will see how easy this question is, how interesting this question is. So before moving on, make sure to subscribe to this channel for regular LeetCode videos like this. Also check the description below. I will post down all the links and the codes that I will use in this, like the exact code that you will write. You will find all those in the description. Make sure to check that as well. So let's start with this video. So question says there are buckets. That is the bucket of liquids. So buckets being given to us. Fine. So that's the bucket of liquids. And it says where exactly one of the bucket is poisonous. All right. So look, buckets is a number. It's not an array. Make sure of that. Okay. So it finds out that there's exactly one of the bucket is poisonous. All right. To figure out which one is poisonous, you feed some number of pigs the liquid to see whether they will die or not. First of all, they are saying to like feed those bucket, the liquid in the bucket, like bucket of liquid is there, so they're saying to feed those liquids to the pig, so that the pigs, like some number of pigs in the liquid, so that whether the pig will die or not. So you need to check. So the by this you can check that you need to find out which bucket is poisonous. Fine. And that's exactly what. So they're saying that you need to feed those buckets to the pigs, and in that what you need to do, you need to realize that which of the bucket is poisonous by seeing whether the pig is dying or not. So the question says to kind of check whether the pig die or not, but please don't kill animals. Okay. So don't get inspired by the question. The question is just for your understanding of maths and problem solving skill. So be careful about that. Okay, let's read further in the question. The question says, unfortunately, you have only minutes to test. So there's the minutes to test for you. That is the minutes to determine which bucket is poisonous. So you are given a specified minute, like a number of minutes, to just check which of your bucket is actually poisonous. Fine. You cannot go beyond that. So you need to do find out some algorithm so that you can check within the given time, that is the minutes to test, which bucket contains the liquid that is poisonous. Fine. So that's your check. So let's see what further it says. You can feed the pigs according to this step. So there are like particular steps you need to follow to feed those pigs. Okay. Great. So it says like choose some live pigs. So the how many pigs you are choosing is completely upon you. There's no bracket on that. Like you can have any number of pigs. So it's like choose some live pigs. Okay, some pigs which are living, and for each of the pig, choose which bucket to feed it. Remember, this bucket is a number, not an this bucket is a number, okay, not an array or something. So it says choose which bucket to feed it. It's like you are just choosing anything, okay. It's not like you are going through an array and giving an array to that. Make sure of that. So it says choose which bucket to feed it, and further it says the pig will consume all the chosen buckets simultaneously and will take no time. Okay, so the pig will consume whichever bucket you will provide to the pig. The pig will consume the whole of it, and it will take no time. Okay, so there's no timing wasted. That is, the minutes to test is not wasted in that. Fine. Then it says wait for the minutes to die. Okay, so there's a another variable given to you. There's a minutes to die. So you may not feed any other pig during this time. Okay, so it says like minutes to die is given to you, so that you need to wait for that timing to check whether any pig dies or stays alive, like survives to the process. Fine. So that's the question is over here. Further, it says like the after minutes to die, after this particular minutes to die have passed, any pig that have been fed the poisonous bucket will die and all other will survive. Okay, so once you this minutes to die is passed, any pig which you have just given them will die. Okay, like remember there's only exactly one bucket. Okay, so after this minutes to die is passed, any pig who have been given the poisonous bucket will die and all other will survive. And once a pig dies, you actually find out which one is the answer. So it says like repeat this process until you run out of time. So run out of time is which time the minutes to test is your time. Okay. So that's the question is all about. We'll understand more deeper into this question. We'll understand the maths behind this question. Let's see the what last points they are giving to us. Like it says, given the buckets, minutes to die and minutes to test, return minimum number of pigs needed to figure out which bucket is poisonous within the allotted time. Okay, so we need to return how many pigs are actually needed to check for those to check which bucket is poisonous. Remember, there's exactly one bucket which is poisonous, but how many pigs are needed to test all the buckets? That is, all the buckets that the buckets number given to us within our minutes to test. Okay, so question is how many pigs can help us? Okay, look, this is a catch. This is a good question. Okay, this is really a hard type question, but you need to understand the math. Once you understand the math, it's easy. I bet this is easy. Just go ahead. I will explain you one by one. So, so you just say the minimum number of pigs. Fine. We need to find the number of pigs. Let's see. Let's take this example. Fine. A bucket there is 1,000. Okay. So there's a number of bucket is given to us 1,000. Fine. Then it says the minutes to die is 15 and minutes to test is 60. Now, see, as per the question, a pig will be observed for the survival time of 15 minutes. Okay, so you need to observe a pig for the 15 minutes, right? So that's what it says that you may not fake. You need to wait for this minutes. Okay, it means that a particular fate couldn't feed in its observation period. That is, when you are observing a particular pig, you cannot feed that pig again. Okay, so it says you may not feed any other pig, but that particular pig you are not feeding again. Fine, you need to wait for that timing. So it says like in his observation period you cannot feed that, but whereas other pigs, like other pigs could be engaged for feeding, right? Once you're observing a pig, for other pigs you can feed them again. So it's like once you're observing one, you can feed other ones. Okay, if a pig or pigs in an observation survives, okay, so we are still have spare time to perform another trial, then we'll engage this pig again in a new trial, isn't it? Say a particular pig you have over here and it's survives the particular bucket you are given to the pig. So and our time is still there, that the ministerial test is remaining, so we can engage this pig in another bucket, right? So we can engage in another bucket and keep testing. So that's the and observe whether it will survive or not. So that's the whole idea. Fine. Now, check over here. What is given to us is a minutes to die or a minutes to die. Okay. So minutes to die was like 15 minutes given to us. Okay. So that's the survival time. Now, the next thing given to us is minutes to test. Okay. Look carefully. This parameter will actually help us to know how many trials can be performed, because you would like you will feed a pig, fine, you feed a pig some bucket, that pig you will wait for this particular minute, then we'll feed another bucket to the pig and wait for this particular minute, fine, and you keep on doing that until how much, until this minutes to test runs out, right? So this minute to test will actually give us how many trials we can perform, right? Isn't it? This minute test will be helpful for us for that purpose, because say here minute test is 60, fine, 60 is there, and we need to wait 15 minutes for to check whether this pig will die or not, fine. So how many times we can feed this pig another next new buckets? So we can go ahead with, see, we can go ahead with 4 buckets, right? Like 15 minutes and we can give the pig 4 buckets, isn't it? So that's the idea, because as the time to test and time to die, okay, so those I'm telling is like minutes to test, the time to test and the time to die given. So considering this both these parameters, we can now know that the peak could participate in like 4 trials only, like 60 you need to you have this total time, and this is the time to die, fine. So you can see that you can, a peak, if survives, can participate in 4 trials only, right? Isn't it? But look here, there's a small catch there. Fine. Let's take it as a like, see this catch. Observe this catch properly. Fine. See, there are 5 buckets. There are like given like 1,000 buckets. So I'm just removing this 1,000. Let's say there are 5 buckets. Fine. There are 5 buckets given to us. Fine. We know that a pig will first eat this bucket. You just gave it 1 bucket. Fine. You waited 15 minutes. The pig survives. You then give it the second bucket. The pig eats it and then wait for 15 minutes. if the pig survives, you again give the third bucket, the pig survives, okay, eats it, 15 minutes done, the pig survives. You gave him the fourth bucket, fine, the pig eats it, and ultimately the pig survives. And look carefully, the pig survives over here. But what is our time to test? Time to test is 16 minutes. So 15 is gone over here. Okay. Another 15 minutes is gone over here. Another 15 minutes is gone over here. And the last 15 minutes is gone over here. So our 60 minutes is over in checking the four buckets. But and we find that the pig, our dear pig, is still alive, right? If the pig survives in all the four buckets, then can we be sure that this is our culprit? This particular last bucket, which we didn't fit to our pig, this one is the culprit. That is, this one is the uh, actual what do you say, this one is the bucket that is poisonous, right? We can say that because the pig survives all the buckets, so there's another bucket that is poisonous and the pig didn't taste that. So we know that a single pig, if there is only one pig, and we know that we can perform four trials, okay, we can I'm not taking you the time and time, so I'm just checking the number of trials we can go ahead with, the number of minutes, the time to take and the time to die. Okay, so there are like four trials we can do in the given time, right? So in the four trials, we know that one pig can do four trials. I'm just taking this particular case. Okay, don't generalize it now. Let's just understand it. In four trials, the pig can actually check how many buckets? Four plus one bucket. Why is it 4 plus 1? Because this is the one particular bucket that the pig didn't test, but we are sure that that's a culprit bucket. Okay, one pig in like four trials can check 4 plus 1 bucket, isn't it? Is it clear? I think it's clear. If it's not, just make sure to comment down. I'll be happy to help you out again in this. I'll be happy to tell you the stuff again in comments as well if needed. But I hope this is clear that a single pig in four trials can actually check five buckets. That is four plus one, right? Say the number was something like something different. Okay, in that case, say like whatever be the number of trials that the pig can go through, actually a single pig can do number of trials, that is t. If I take number of trials as t, and the pig can check for t plus one bucket, right? If here in our particular example that we are looking for, that is the example one, in that there are like four trials and you find 4 plus 1 bucket can be checked. So if there are different number of trials, a different number of trials like t, so a pig can check, a single pig can check t plus 1 trial or t plus 1 bucket, right? So that's the idea. That's a small catch you need to remember. That's the catch in this question. The question wants you to explore this particular case, and this is the corner case, and that makes the question a hard type question. Remember this. Now, moving ahead, okay. Let's take another like a small scenario. If there were we saw like if there are five buckets, then in this particular example, the pig can a single pig can check it in 60 minutes. Done. And what if there are like six buckets? Okay. Okay. Just think that you remember this part. I'll come back to this because this will be an important part in our question as well. That is t plus one is needed. Now, let's say there are like six buckets out there, or we took it as five buckets initially. So now say there are six buckets. Okay. And the time to test is 60 and time to die is 15. So a single pig can check five buckets. We know from here the single pig can check five buckets, but we are still left with another one bucket. So what can we do with that, right? Can we do anything to just find out for how is the last bucket going on? Because say there are like another bucket over here, so we are we sure that whether the poison is in this bucket or the poison is in the next bucket, right? There are two buckets remaining. So in this kind of scenario, you are going to deploy another pig. Okay, in this scenario you are deploying another pig to actually find out which bucket is the one, because once you got 6 till 10, okay, in that case, like one pig can go ahead with five buckets, second pig can go ahead with another five buckets. So in that scenario, you need, whether it's 6 or it's up to 10, you need to deploy a second pig, right? So that's the idea. Okay, auto detection is not possible in this scenario once it is going out. So that's where you are deploying more number of pigs. Okay, so that's the location you are deploying more number of pigs, and that's the thing you need to count. That's where you are counting the minimum number of pigs. Fine. Now let's see. Let's try to generalize this. Fine. So if we allow n pigs to fit together, okay, if our n number of pigs are eating together or fitting together, let me just clear all this out, and then I'm just going ahead further with this. Okay, but before I clear this, remember this particular thing. Okay, a single pig can take in this formula, and like remember how this plus one is coming. So this is important. So let me erase this out and go ahead with further steps. Fine. Say uh, like if we allow n pigs to fit together, fine, then total number of buckets then we can test all together. Like we can, like those pigs can test together is how much? It can be like 4. I'm just going with this particular example number 1. Okay, that this 4 I'm taking. So 4 is like this 60 by 15. Okay, so that's the idea. So now that's like 4 plus 1 a single pig can do, and we are doing all the peaks simultaneously, right? So when we're doing multiple peaks simultaneously and we are trying to check n number of we have deployed n number of peaks, so how this is calculated? This is where we do multiplication, right? We don't do summation in this case. That's what you might remember from the permutation and combinations chapter, that we are deploying it simultaneously. So how will it go? So the second peak will be like 4 plus 1. Okay, and then we'll again multiply, and the third peak will be like 4 plus 1, right? So this will go on till n number of pigs. Okay, up to n times, that is n number of pigs. So what this formula is, this is like 4 plus 1. Remember how we got 4 plus 1? So 4 plus 1 to the power n, right? That's to the power n. That's the number of, like if you have n number of pigs, then we can come across to this. This is the result we can check. That means if we had 5 buckets, then in 4 trials, 1 pig could have got us 5 buckets cleared. But if we have 25 buckets with 4 trials, 2 pigs can clear out 25 buckets. So that's the idea, right? That's the whole idea. So let's generalize, try to generalize. We are taking the same minute and time. Okay, so let's say we are trying to generalize that. What is this n? N is rather determining the number of pigs. So that is like 4 plus 1 to the power the number of pigs. So you're finding number of pigs is what? Is like less than or equal to your number of buckets. Number of buckets, say we are taking a capital N. Fine. So that's the number of bucket, because up to 25 buckets can be checked with for like 2 pigs, right? In our 4 plus 1 time limit. So that's the idea. Now this 4 is what? The 4 is actually the number of trials. Number of trials we are getting from minutes to test divided by minutes to die. Like, so this is the number of trials. I'm taking it as t plus 1. Fine. T plus 1 to the power the number of pigs. Number of pigs needed is less than equal to n. So for our ease of calculation, let's consider is equal to n. Fine. So that's less than, we'll know that this is less than equal to n. Okay, fine. Now after that, what we can take, we now know, like, to calculate this, how we'll go ahead. We need to count the number of pigs. That is our question, is the minimum number of pigs. So how will it go? If number of pigs p, we need to calculate p. How we can go ahead with that? We can simply do log of that t plus 1, right, equal to a p into log of t plus 1 equal to log of n, isn't it? That's the formula. So further, we'll simply find the p, that is the number of pigs we needed, is basically log of n divided by log of t plus 1. So that's the question we have. That's the number of pigs we need to calculate, right? So what is this t? We found it by dividing number of tests divided by number of like time to die, minutes to die, test divided by minutes to die. That's the t. And what is this n? N is our number of buckets, right? So n is the number of buckets, and we exactly know what we need to find out. We got our answer, we got whatever we are looking for, and we got this. So here we are not using any of the data structures, any of the huge algorithm. This is pretty much simple maths we are using. We are using maths to just find out. I will show you another way where you can use some kind of loop, some kind of stuff to calculate the same thing. We'll do the same exact thing. but we will use like loops to do that. That's the second way. So let me just quickly write this out, the exact formula, this exact formula. Remember this formula, okay? So let me just quickly write this formula for you and run this our code. Fine. How about this? Looks good. Let's go ahead with that. I will not erase this raw formula that we wrote, right? Rather, I will erase everything that I wrote over here. Fine. Just give me a second. So let me just write this exact code that I just sent you over here. Okay, let's write this code and let's try to run this. Okay, so first thing is we need to find this number of trials, which is t. Then we'll simply use this formula. Fine, let's go ahead with that. Look here, our particular submission works for a 0 millisecond solution. This is the fastest. Fine, that's the 100% of the Java. Let's see what exactly we did. We did exactly what we wrote in our formula. We just did math.log buckets. That's the n. We say that's the n. Okay, n being the number of buckets in our formula. Okay, divided by math.log. That is a log. We're doing logarithm of trial plus one. Trial is the one. We just took the division. Okay, that's how we just found out. And ultimately, we just did math.sil. So what this math.sil does, math.sil is basically this rounds the specific double value. So this division returns as a double value, and this sil function like rounds this double value in upward and returns it. Fine. This round off is going on, and after that we did a math of still and returned, and we just returned it as an integer because integer is the return type for us. Fine, and that's the exact answer we ask us to do, and you can see we our answer gets accepted. It's a pretty fast solution because you cannot do much faster. What else you will do? This is maths. Fine, so that's the solution we got. We just derived how we can do that, and that's how we just found out this is our answer. That's all we need to do. We just got with our answer. Fine, so this is one way to do that. In a second way, if I just tell you what can be a second way to do that, the second way will be you need to find this number of trials. Okay, you need to find this number of trials, and then you need to do a count. Okay, you need to do a count being you need to keep on multiplying like total you can reach from like number of buckets or like the number of trials you are going on. Like with each trial you need to keep increasing our count. If I just show you immediately, look here. Look, this is basically you're using a much more memory. That's what like LeetCode compiler is telling us. What we are doing, we are rather finding a total. We're taking a total to be one initially, and we're counting the number of that's the count of the pigs we have. Fine. So every time our total is less than the number of bucket, so total is like we're trying to reach like how many bucket we can reach. And see what's the trial, we just increased it by number one. Why was it we increased it by number one? That reason being that exact reason we saw that if there are four trial we can do, then a pig can check 5 buckets, that is checking for the one extra bucket which we cannot do it. Okay, like which we need not to check, right? That's the corner case we just discussed few minutes back. So that's the plus one. So I just took the plus one directly over here, and we're just doing total into trial. That is we are just total into trial being this number of that's what we are doing, right? We just multiplied. If you remember 3 minutes back, I was just saying 4 plus 1 into 4 plus 1 into 4 plus 1 until n times. That's what we started the derivation of our formulation, right? So that's derived the formula and did a logarithm of that. But you are now doing a forward step. The other way, we came back from the total and directly did a logarithm to find our answer. But here we are going forward with again and again multiplying the total with our like trial number of trials with the total, and counting the number of ships like number of pigs we need. Okay, so that's the basic idea. One you are going forward, other you are coming back. So that will be a kind of way you can see, but the mathematical formula we just saw right now. So that's more or less about this video, guys. Thank you for watching this video. I hope I can make you understand how we can solve a question like this. Make sure to comment down if any of your doubts you have regarding this. I'll be happy to help you out in this.
Okay. If you just like this video, that will be helpful for me. That motivates me to make such more videos for you again and again. So that's all about this video. Hope to see you soon in my next video as well. Thank you all for watching this video. Thank you.